This is a video on factoring a monomial from a polynomial. And let's talk about what factoring really means. So to factor an expression means to write it as a product of its factors, which might sound like a weird definition, right? Because you're using the word factor in there to describe what factoring is. It might be more clear if I write it like this. If I said if A times B, right? So two numbers, A and B, multiply together to give you C, then A and B are called factors of C. So if two numbers multiply together to give you a third number, those things are called factors of the number. So just a little quick example here. So for example, if I said 4 times 5 equals 20, then what can you say about 4 and 5? Well, then I could say then 4 and 5 are factors of 20. Just like here, if A times B equals C, then A and B were called factors of C. Here, 4 times 5 equals 20, so 4 and 5 are factors of 20. And that's the way we kind of use the word, factors. If I asked you to list all factors of 20, right? So if I said list all factors of 20, that's similar but slightly different, right? 4 and 5 are factors of 20, but they're not the only two things that multiply to give me 20, right? What other whole numbers multiply to give 20? We said 4 and 5, but also 10 times 2 gives you 20. And also, don't forget 20 times 1. For any number, right, 1 in itself are always factors. So you always want to consider that. So if I was listing all the factors of 20, I might list them as 1, 2, 4, 5, 10, and 20, listing them in order ascending. But if you list them in pairs, it's probably the easiest way to find them all. We'll talk a little bit more about that later, but just making sure we understand that, for a number to have factors, it could have more than one set of factors. For a variable, we also can talk about factors. For example, if I said I had y to the second power times y to the third power, I know that should equal y to the, remember when you multiply things at the same base, you add their exponents, so y to the fifth power. But that gives me some information. If these two things multiply together give me y to the fifth, then I could say then y to the second and y to the third are factors of y to the fifth. So that's something that if you have two things multiply together, give you a third thing, right? Those two things are called factors of that third. So it applies to variables as well. Now, just like we did with 20, y to the second and y to the third aren't all the factors for y to the fifth. So if I actually asked you to list all factors of y to the fifth, let's think about what we could have there. We have what I just said above, right? Y to the second times y to the third. That's one way to get there. So recognizing that the way you get factors for y to the fifth really is that their exponents have to add to give you 5. Well, that also means that if you had y times y to the fourth, that also will give you y to the fifth, right? Because the exponent on the first y is 1. 1 plus 4 gives you 5. And then don't forget that 1 times itself is always a factor. So 1 times y to the fifth, because really the 1 is like y to the 0. Something to keep in mind here is that we're not going to use negative exponents, so these are only the positive exponents that end up being factors, at least for y to the fifth. But something I want to point out, and this is kind of really the more important part about this, is that if I list all the factors of y to the fifth, starting with 1, and I write them in, powers from lowest to highest, if I had 1, I'd have y to the second, y to the third, y to the fourth, and y to the fifth. So all the factors of y to the fifth are really 1, and then just every power of y up until y to the fifth. And that's going to be important as we talk about factoring later on. When we talk about factors for a variable, all the factors up to and including the power on that variable are factors for the variable. So that's all the factors for y to the fifth. So when we talk about factoring, I'm just going to write this as a note here. We'll do a little bit more of this later in the section, but this is kind of my own layman's way of saying it. Factoring is undoing multiplication. So when I say that, right, factoring is undoing multiplication, what I'm really trying to figure out is when I get directions that say to factor, I'm trying to figure out what things multiplied together to give me what I have now. So you're trying to work backwards from multiplication. So, for example, if I said to factor, and the first one I'll look at is 2x plus 4. And we'll do this more formally in a minute, but just kind of talking about this together. If I have 2x plus 4 here, what I'm really looking for when I say to factor is I want to know, what multiplies together to get me to 2x plus 4. What can I break it down to? And what you want to do is look at each term individually and find a common factor for each term. And usually we call it the greatest common factor for short. We'll call it GCF. And I'll write this out more formally in a second. But you want to look at each term and you want to say, okay, 2 and 4. Well, what factors do they have in common? Well, the factors for 2, remember, are 1 and 2. The factors for 4 are 1 and 4 or 2 and 2. We want the greatest factor that's common to both of them. So 2 is the largest factor that's common to both 2 and 4. So the GCF here would be 2. In other words, right, here's the factors of 2. It's just 1 and 2. Here's the factors of 4. It's 1 and 4 or 2 and 2. The largest one that's on both lists is 2. You can't take any factors of x out because the first term has it, but the second one doesn't. So when I do this, the way we do it is we usually write the GCF out in front. And then in parentheses, because remember parentheses represent multiplication, and I'm trying to undo the multiplication to show what it was, I'm going to put whatever's left over when I divide 2 out of each term. Because remember, if I'm dividing 2 out of each term, that's me undoing the multiplication. So if I have 2x and I factor out a 2, it's like dividing a 2 out. So 2x factoring out 2 or dividing by 2 gives me just x here. And then 4 factoring out the 2 or 4 divided by 2 makes us a positive 2. So 2x plus 4 really factors down to 2 times x plus 2. We'll look at one more and then I'll give you some formal stuff. If I said I wanted to factor 3x to the fourth plus 6x to the third power. Again, when I'm factoring, the first thing you always do is you're going to look for this greatest common factor for both terms here. All right, and the largest one that they have in common. So first off, look at the coefficients of 3 and 6. So we'll look at those first. The factors of 3 are 1 and 3. The factors of 6 are either 1 and 6 or 2 and 3. The largest value that falls on both lists is 3. For the variables, we have x to the fourth and x to the third. We want the greatest common factor between x to the fourth and x to the third. Now, if you remember how this works for variables, we talked about in this example earlier with the y's, the factors for a variable are all of them listed up until that power that you see. So the factors for x to the fourth, right, if I was to list them out, would be 1x, x squared, x to the third, and x to the fourth. The factors for x to the third would be 1x, right, 1x, x squared, and x to the third. And what you're looking for here is you're looking for which one is the largest one, right, the greatest one that's common to both lists. Well, what's common? Well, it's x to the third. So my GCF here is going to be 3x to the third. Now, keeping in mind that even though we're looking for the greatest common factor, right, it's really the lowest power that you see because it has to be the one that's the largest to both lists. So it'll end up always being the lowest power that you see. So when I go to factor this, remember how this works. I'm going to write that GCF out in front, the 3x to the third. And then parentheses, remember how it works. We're undoing multiplication. You divide by the GCF. So 3x to the fourth, dividing out 3x to the third from it is really how we factor it out. So 3 divided by 3 cancels to a 1. X to the fourth divided by x to the third is just a single x. So 1x is just x. Plus, because that's plus, 6x to the third divided by 3x to the third. 6 divided by 3 will give me 2. X to the third divided by x to the third cancels to a 1, so we just leave it. So we have 3x to the third times x plus 2. So that's how you would begin factoring. I'm going to write out some formal things here just so you have them for your notes. But it's really what I just did a second ago, right? So to factor a monomial means single term, from a polynomial, right, something that has multiple terms, we use the greatest common factor, which we call the GCF. Right, so we use the greatest common factor. You may have seen this before when we were talking about simplifying fractions. So we look for the greatest common factor for all the terms. The GCF, right, the greatest common factor, is the product of the factors common to, and this is important, all terms in the polynomial. When I say that, right, that it's a common factor that's common to all terms, right, the product common to all terms, what I'm really saying is if we go back up here, notice in the second example, in example B, we took, from the coefficients and the variables because we had x's in both terms. In the first example, though, we didn't have x's in both terms, so we couldn't take any x's out, so there were no x's common to all terms. In this case, x to the third was common to both terms, so we could take it out with it. I just want to do a little exercise just to make sure that, if I was asking you to determine the GCF for two values, you could find it pretty easily, or at least have a strategy to find it. If I said determine the GCF, remember greatest common factor, for 48 and 80. Now when we do this, you might know off the top of your head, it might be obvious. If you know your multiplication facts, that helps a lot here. You especially need to know your multiplication facts when you're talking about factoring because we're always talking about undoing multiplication. So if you don't know what things multiply together to give you a number, it makes it more challenging to figure out what you would use. So let's say you didn't know. All right, so what I'm going to do is I'm going to list the factors for each, kind of like what I did earlier. But this is going to be the factors of 48, and I'm going to give you a strategic way to do it. All right, I would always start with 1 in itself. All right, so 1 and 48. And then I just try the next number. So I'm going to try 2. So is 2 a factor of 48? Well, the way you know is if 48 divides evenly by 2, then it is. If 48 doesn't divide evenly by 2, then it's not. Well, 48 divided by 2 gives me 24. In other words, 2 times 24 gives me 48. And I'm going to try 3. Is 3 a factor of 48? Well, 48 divided by 3 gives me 16. And I'll try 4. Is 4 a factor of 48? Well, 48 divided by 4 gives me 12. And I'd say, okay, is 5 a factor of 48? Well, 48 divided by 5, if you're doing this on a calculator, you'll see it doesn't come out evenly. In other words, it comes out with a decimal number. So 5 is not a factor of 48. And then how about 6? Well, 6 is a factor of 48 because 48 divided by 6 is 8. In other words, 6 times 8 gives me 48. And then is 7 a factor of 48? Well, if you did 48 divided by 7, it doesn't divide out evenly, so 7 is not. And then next number would be 8. Well, 8's already on our list. That's how we know we're done. Once you get to a number on the left side that you already have on the right side, you've listed all the factors. So if you approach this strategically, you could do the factors of any number like this. So if I look for the factors of 80 now, because that's the other value I was looking for. What are the factors of 80? Well, we start with 1 times 80. Now we say, okay, is 2 a factor? Well, 2 times 40 will give me 80. Is 3 a factor? Well, if you do 80 divided by 3, it doesn't come out evenly. Is 4 a factor? Well, 80 divided by 4 is 20. Is 5 a factor? Well, 80 divided by 5 gives you 16. In other words, 5 times 16 gives you 80. Is 6 a factor? Well, 80 divided by 6, that doesn't come out evenly. Is 7 a factor? No, 80 divided by 7 doesn't come out evenly. Is 8 a factor? Yeah, 8 times 10 will give you 80. Is 9 a factor? 80 divided by 9 doesn't divide out evenly. And then 10 would be the next number we try. 10's already on our list, so we're done. So now the question is, we want to determine the GCF, the greatest common factor. The greatest common factor means the largest value that falls to both lists. Well, the largest number that I see in both lists would be 16. So the GCF here equals 16. Now, it's not the only common factor. It's just the greatest one is 16. There's other common factors, right? You see 2 on the list, 4's on both lists, 8's on both lists. So there are numbers that fall on both lists that aren't the greatest common factor. And they're still common factors, so they're helpful to know. But if they're not the greatest, that's not the one that we want. We want the largest one. All right, so the largest one that's common to both lists, or the greatest common factor, is 16. Another way people approach this is by using prime factorization. Prime factorization really means that you want to make your value equal to the product of prime numbers listed as powers. So if I was to do it for 48, just to kind of give you an example of how it works. So this is another approach. It's really personal preference. If I said I have 48, remember the prime numbers are numbers that only have factors of 1 in itself. So, the first prime number is 2, then there's 3, and then, there's 5, there's 7, but not 8, not 9, right? Not 10, but then 11. So you want to use those kind of numbers. So I'm going to start just by using 2 if I see it's an even number because it's easiest to do. 48 divided by 2 gives me 24. So I'm breaking it down to 2 times 24. And then I want to keep breaking down the number that's left that's not prime until I have only prime factors left. So 24, if I was thinking about it, I could write as 2 times 12. Now 2 is a prime number, so I'm done there. Now looking at the 12, I can write this as 2 times 6. 2 is a prime number, so I'm done on that one, but 6 can still have other factors. 6 I could write as 2 times 3. And now 2 and 3 are both prime numbers, so that's how I know I'm done. So when I want to write 48, what I know about 48 is that I can take the product of these, right, and they multiply. 3 times 2 times 2 times 2 times 2 gives me 48. In other words, 2 to the 4th power times 3 is a way of writing that. That's called, what we say is the prime factorization for 48. You're just writing it as a product of prime numbers. All right, we can play the same game for 80 over here. 80 is 2 times 40. 2 is prime, so I'm done there. 40, if I want to factor that down, I can write as 2 times 20. And then 2 is prime, so we're done with that one, but the 20 breaks down. I can write as 2 times 10. And then again, 2 is done. We can break down the 10. 10 is 2 times 5. Now these are both prime numbers, so that's how I know I'm done. So my prime factorization for 80 is equal to 2 times 2 times 2 times 2 times 5, which means it's 2 to the 4th times 5. So if I'm looking for the GCF here between these two values, right, comparing these two, the greatest common factor, kind of like what we did for variables, right, they have what in common? Well, they have 2 to the 4th in common. So the GCF here would be 2 to the 4th. Well, what's 2 to the 4th power equal? Well, that equals 16. So you still get 16. It's just another way to get there. If other factors were common on each side of these, right, if these had other common factors, you would need to use them here. Like, for instance, if this had a 3 and this also had a 3, you'd have 2 to the 4th times 3 in here. But it's just another way to get there. So you should know how to find the greatest common factor. If you know them right away, if you know your multiplication facts, that helps a lot. But if you don't, these are two other ways to approach it, either making lists or using prime factorization. Let's do another example here. If I said to determine the GCF of y to the 2nd power, y to the 6th power, and y to the 9th. Now, it might be obvious to you, it might not. Remember, for variables, the way it works is that the factors for each variable are 1 and then all the powers up until that highest power you see. So if I was listing the factors of y to the 2nd power, well, the factors are 1, y, and y to the 2nd. For y to the 6th power, the factor would be 1, y to the 2nd, y to the 3rd, y to the 4th, y to the 5th, y to the 6th. And if I was listing the factors for y to the 9th, again, 1, y to the 2nd, y to the 3rd. I think you get the idea. This goes all the way up until y to the 9th. So if I'm looking for the greatest common factor, I just want the largest one common to both lists. Well, the one that's largest that's common to both or to all three lists, I should say. The one that's largest common to all three is y to the 2nd. So even though we're looking for the greatest common factor, the one that you want is actually the lowest power you see, because it's the largest one that'll show up on all the lists. So the GCF here is y squared. And I'm just going to write this out. So to find the GCF for variables, you want the lowest power of that variable that appears. So when I say that, it's really important to understand that, the variable still has to show up in all your terms. But if it does show up in all your terms, you want the lowest power that you see. All right, and now we'll talk about our steps for factoring. So we already did this earlier, actually, in the examples where I said factor, but we'll write it out a little more formally here. So if I said to factor a monomial from a polynomial. And when I say to factor a monomial from a polynomial, I'm really saying I want to factor out the GCF. First thing you want to do is determine the GCF, greatest common factor, for all terms in the polynomial. All right, so this is always going to be your first step when the directions are factored. Later on we'll have more complex problems. But the first thing you always do is look for a GCF. Once you've done that, the next step is that you want to factor it out, essentially. So you want to write your polynomial has a product of the GCF and what remains when it is divided out from the polynomial. So you take the GCF, you're going to factor it to the front, and then remember we wrote parentheses after it. Within those parentheses, you write what's left over when you divide the GCF from each term. All right, so we'll look at a couple examples here. If I said to factor, right? So the directions here will say factor. Typically we mean factor completely. In this section, you know, since this is really the first step in factoring, we're just going to try to factor out greatest common factors. And I'll start with 8y plus 12. So, first thing we look for when we factor, we want a GCF, a greatest common factor. Comparing 8 and 12, we want the largest number to factor of both. So for 8 and 12, the GCF will be 4. Be very careful here. Remember, 2 is a common factor for 8 and 12, but it's not the largest, right? The greatest common factor is 4. And then here we have a y, but here we don't, so we can't take any y's out. Because remember, you can't factor it out unless it's part of all the terms. So we can't factor out any y. So GCF is just 4, so we write 4 in front. And then in the parentheses after it, make sure you put the parentheses. You need it because that signifies multiplication. Remember, we're undoing the multiplication. So 8y divided by 4, or factoring out of 4, leaves me with 2y. This is a positive 12, so we know it's going to be positive here. 12 divided by 4. So 12 divided by 4 gives me a positive 3. So when you factor the 4 out of there, you get 4 times 2y plus 3. The way you check, right, if you were to factor and see if you're correct, is you distribute back in, right? If you distribute the 4 back through, 4 times 2y would give me 8y. 4 times a positive 3 gives me a positive 12. So I'm undoing the multiplication, right? I'm figuring out what I multiplied together to get me to 8y plus 12. Let's take a look at another one here. So if I had 4x to the third power plus 10x to the 7th power. Again, our first step when factoring, look for the greatest common factor. In this case, between 4 and 10, the GCF for the coefficients would be 2, right? So largest number to factor, both 4 and 10. And then I have x to the third and x to the 7th. Now, since I have variables in both that are the same here, I want to take out, right, something with x, and you want to take the power that is the lowest, because the highest one that's common to both of them is factor. So I want 2x to the third. So you don't want to have to list out the factors every time. What you're really doing is you're looking at, okay, these both have x's in here. I want the lowest power of x I see because it's the largest one common to both lists. So the GCF is 2x to the third, and you write that in front. And then in the parentheses after it, remember how you factor. We factor really by dividing out whatever you put in front. So 4x to the third, factoring out 2x to the third. 4 divided by 2 gives me 2. X to the third, taking out an x to the third cancels to a 1. So it's just 2 times 1, which we just write as 2, right? Plus 10x to the 7th, factoring out 2x to the third. Remember, you're dividing it out. 10 divided by 2 gives me 5. X to the 7th divided by x to the third. Remember, when you divide things with the same base, you subtract their exponent. So 7 minus 3 means there's x to the 4 left. In other words, there has to be 7 total here. You took out 3. How many are left? Well, there's 4 left. All right, how about if we look at this one here? If I wrote negative 8x to the 5th plus 4x to the 4th minus 12x squared. So we want to factor this. First thing we want to look for is the greatest common factor. And something I would mention, that when you factor, you always want to take out a negative if your leading coefficient, right? If your first term, right, the one with the highest power on it, has a negative coefficient. And the reason you want to do that is because later on it'll be easier to factor when we get to the next sections. So I'm going to factor out a negative because I know the first term is negative, and then I'm still comparing the numbers, 8, 4, and 12, and I'm looking at all three of them, and I want the greatest common factor for all three, the largest number that's a factor for all three of them. Well, 8, 4, and 12 all share a 4 as the greatest common factor. Remember, you want the largest. And then for the variables, I have x to the fifth, x to the fourth, and x squared. So I know I can take out some x's because they belong to all of them. And I want to take out, remember, the lowest power of it I see because it's the one that's largest to all the lists of factors. So it's x to the second power. So you want the lowest power you see for the variable. Once you have the GCF, so negative 4x squared, we put in the front. We're factoring it out, remember, so I'm really undoing the multiplication. So I'm dividing this. When I divide this, negative 8x to the fifth divided by a negative 4x squared. A negative over a negative makes this really a positive, right? So make sure you realize the sign's going to change. And this is going to be a positive 2. And then x to the fifth divided by x to the second. Remember, you had 5 minus 2, so there's x to the 3 left, right? So you're looking at how many were there total. And you're taking away the 2 of them, so there's 3 left. The next term, I have a positive 4x to the fourth divided by a negative 4x squared. So I know it's going to be negative. 4 divided by 4 will give me a 1. X to the fourth divided by x squared would just give me x to the second power, because 4 minus 2 is 2, so this is just minus x squared. You don't need to put the 1 in front. And then here, the last term, negative 12x squared divided by negative 4x squared, so a negative divided by negative makes it a positive. 12 divided by 4 gives me 3. X squared divided by x squared cancels out to a 1, so it's just plus 3. And then you got it here. You can also have more than one variable in the polynomial, remember? If I asked you to factor something that looked like this, if I had 33x to the fourth y plus 15x to the third y squared minus 6x squared y to the third. You're still doing the same thing. If the directions say factor, the first thing you always do is look for a GCF. Looking for that greatest common factor. So, between 33, 15, and 6, we want to look for the greatest common factor between them, and that would be 3. They all share a common factor of 3. And then you're looking at the variables. Well, you have x to the fourth, x cubed, and x squared. So they all have x's. I can definitely take an x. And I want the lowest power of x I see, which is x squared. Then we got y to the second, y to the third. So they all have a y, so I can definitely take y. I want the lowest power I see, which is just y to the first power. Remember, you're taking the lowest power you see because it's the largest one that's common to all of them. So we got 3x squared y, and we write that in front. And then in the parentheses that follow, remember when you factor, you're undoing multiplication, so you're really dividing out when you factor. So 33x to the fourth y, factoring out a 3x squared y. 33 divided by 3 gives me 11. X to the fourth, factoring out x squared leaves me with just x to the second. We factored out y from there, right? So y divided by y just gives you 1, so it's 11x squared for my first term. And then we move to the next term. A positive 15x to the third y squared, factoring out a 3x squared y means you're dividing it out. So positive divided by a positive will keep this positive. 15 divided by 3 is 5. X to the third, taking out an x squared, leaves me with just x to the 1. Y squared, we took out one of the y's. That means there's still one y remaining, so y to the first power there. So 5xy is the middle term. Because remember, y squared minus, the 2 minus the 1 in the exponent here makes that just 1 left. And then the last term, we got negative 6x squared y third, factoring out a 3x squared y. So negative 6 divided by a positive 3 is going to keep this negative, makes it negative 2. X squared, we took out the x squared, so those cancel out to a 1, so we don't need to write it. Y to the third, factoring out a y gives me y to the second power. It's 3 minus 1 leaves me with 2 left. And then we factored it out. Let's take a look at a few more. if I wrote 6x squared y to the third minus 18x squared y to the fourth plus 30x to the third y to the seventh. So again, I'm looking for a greatest common factor. And if I'm looking for a greatest common factor here, remember you're looking at the coefficients. So 6, 18, and 30, the greatest common factor, the common factor that is the largest one to all three, would be 6. For the variables, I got x squared, and x to the third. For the x's, since x's are in all of them, I can take an x out. Remember, I want x to the lowest power I see, so it's supposed to be x to the 2. And then we have y to the third, y to the fourth, and y to the seventh. So they all have y, so I can definitely take y. And remember, again, you want the lowest power you see. So the GCF is 6x squared y to the third. So remember how it works. You write the GCF in front. And make sure you write it in front. If you don't write it in front here, you don't have a product anymore. And then that means you wouldn't have something that, you know, when you factored it would multiply back together. So 6x squared y to the third, and then parentheses. When you take the GCF out, remember you're dividing it out. So the first term is 6x squared y to the third. I'm dividing out or factoring out the 6x squared y to the third. Well, that all cancels out. When everything cancels out, make sure you write the 1. All right, so if everything cancels, you need the 1 there. If you have, you know, only parts of the term canceling out, you don't need the 1 because the other parts will times 1 just be themselves. But here, if everything cancels, you need to have 1. The next term, I've got negative 18x squared y to the fourth, factoring out 6x squared y to the third. Well, we know it's going to be negative because it's a negative divided by a positive. Negative 18 divided by 6 makes that negative 3. X squared, factoring out the x squared, those cancel out, so I don't have to worry about that. Y to the fourth divided by y to the third gives me just y. And then for the last term, positive 30 divided by 6 makes this positive 5. X to the third, you're taking out x squared, so you just have a single x. Y to the seventh, you took out y to the third, so you're left with y to the fourth. And then you factored it. Remember, you're looking for the greatest common factor when you're factoring it out. All right, how about take a look at this one here. If I said I had 8y to the seventh minus 2y to the third plus 6. First thing you look for when you're factoring always is the greatest common factor. So between 8, 2, and 6, we know the greatest common factor between them would be 2. Here I've got y to the seventh, y to the third, but I don't have any y's in the last term. So remember, you can't factor out any y's unless it belongs to all the terms. So you can't take any variables in this one. The GCF is just 2. All right, so be careful. That's a common mistake. People try to take the y's out of this, but there's no y in the last term. You can't take any of them out. It has to be common to all terms. So we factor 2 to the front. 8y to the seventh, factoring out 2 means you're dividing it by 2, which gives me 4y to the seventh. Negative 2y to the third, factoring out 2. So negative 2 divided by positive 2 makes this negative 1, and then y to the third just comes along because, you know, there's nothing to divide it by. And then we got plus 6, factoring out the 2. 6 divided by 2 would just be plus 3. And then I factored it out. So sometimes you're just going to take out a constant. You're not going to take any variables. We'll just look at a few more. If I wrote this 9xy plus 7y, the greatest common factor here. Between 9 and 7, 9 and 7, you know, the factors of 9 are 1 and 9 or 3 and 3. The factors of 7 are just 1 and 7. So the only factor they have in common for the coefficients is just 1. And we typically don't write that because taking a 1 times something is always just itself. So the greatest common factor for the coefficients is 1. We're not going to factor that out. Here you have an x in the first term, you don't have an x in the second term, so you can't take any x's out. Here you have a y, here you have a y, so we can take out a y, and you know, it's y to the first power is the lowest we see, so we just take out y to the 1. So when I factor out my GCF of y, that goes in front. 9xy factoring out y means divided by it. So 9xy divided by y just leaves me with 9x, because the y's are going to cancel to a 1, plus 7y divided by y just gives me plus 7, because the y's cancel out to a 1. So you have y times 9x plus 7. So sometimes you might just factor out a variable, and that's okay too. Looking at these next two examples get you ready to kind of factor in a more complex way. So we'll look at it, just two more here. If I wrote this 9x and then in parentheses 2x minus 3 plus 7 times 2x minus 3. Let's be careful we don't forget what our directions are. Our directions are to factor. All right, so you want to factor. And when you factor, you're looking for a greatest common factor between all the terms. So the first thing to understand here is how many terms do you see to begin with? This is actually two terms. Remember, the terms are separated by addition or subtraction. This is all multiplication here. So that's one term. This is all its own term. So you have two terms here. And what we really want to say is, okay, what do those two terms have in common? What factors do they have in common? Well, 9 and 7, you know, those don't have anything in common. This has this single x in front, but doesn't have any x's in front, so you can't have anything in common there. And then we got this 2x minus 3. This has a 2x minus 3. So the GCF in this case is 2x minus 3. It's actually very similar to the example above. Just realize where the y's were, I put 2x minus 3. It's the same example. So the point being is that, you know, this factor here is just called y. In this case, this factor is called 2x minus 3. But it's really just, you're looking at each term and seeing what factors they have in common. What you don't want to do with this problem is distribute through at the beginning. That's the common mistake people make, right? This says factor, we want to factor out. We don't want to distribute. So you want to factor out from here. So you have 2x minus 3. And remember, you write that in front. Make sure you put parentheses around it, because the entire 2x minus 3 times whatever's left over in parentheses after it. So make sure you have parentheses around that 2x minus 3 when you put it out in front. When I factor that out, we have 9x times 2x minus 3. You're dividing out 2x minus 3 from it. Well, that means those are just going to cancel out. You're going to be left with 9x. And here, this is positive 7 times 2x minus 3 divided by 2x minus 3. So it's going to stay positive. Well, the 2x minus 3s are going to cancel out. You're left with plus 7. And so when we factor this, we got 2x minus 3 times 9x plus 7. Make sure you have parentheses around both of those. But it is the same setup as the one above, right? It's just that instead of calling this last variable y, I called it the factor of 2x minus 3. All right, let's do one more like this. If I said I had 4x times 3x plus 7 minus 9 times 3x plus 7. Again, don't let your instincts lead you astray. You don't want to distribute this, right? The directions are factor. When I factor, I look for a greatest common factor, right, between all the terms. Well, how many terms do I have? I have 2 terms. So the GCF here between the first and the second term, 4 and 9, they don't have any common factors other than 1. We have x here. We don't have any x's to a power here, so you can't take any x's. And then you have 3x plus 7. You also have 3x plus 7 there, so you can factor out 3x plus 7. So 3x plus 7 is our GCF. We write it out in front in parentheses. Remember, you need the parentheses because the entire 3x plus 7 is what's going to be multiplied to whatever's in the parentheses after it. So when you look at this last part here, right, what's left over? 4x times 3x plus 7. You factored out 3x plus 7, so those are going to cancel out when you divide it out. You're just left with 4x. Here, negative 9 times 3x plus 7, you divide out the 3x plus 7, you just get minus 9. And so that factors the 3x plus 7 times 4x minus 9. The important thing to recognize here is that when you're done factoring, you should have a product. You should have things that are being multiplied together, and that's what we have when we do this. So we factored it. This part here, this last couple examples that we did, this is going to be an important step when you do factor by grouping, which we're going to do when we have 4 terms. So in the next sections, you'll learn about factoring by grouping, and this is going to be, a step in that process. So that's why we covered those. So hopefully this video is helpful. Make sure you practice factoring out of GCF. It's always the very first step when you're factoring. No matter what type of factoring problem you have, you always want to look for a greatest common factor first.